Welcome to the Bayes Server channel. Bayes Server is a powerful tool for building Bayesian networks and causal AI models. In today's tutorial, we're going to be working our way through the Auto Insight tool, which comes under the analysis suite of tools within Bayes Server. So what is Auto Insight? Well, it allows us to consider a variable such as whether someone purchases a product or not, or whether someone has a specific medical condition or not. And we can then look at how one state, say purchase equals true, differs from purchase equals false, or a particular medical condition being true versus false. It's not restricted to just two states. It could be how one state differs from all the other nine. The Auto Insight tool also supports continuous variables as well as discrete variables, or networks in which you've got both, which we tend to call a hybrid network. We will be using the built-in Bayesian network. So from Bayes Server start page, we can see there's lots of built-in example networks here. We're going to be using a fully discrete network here called the Bayesian network. There's also one called Waste, which you might want to take a look at and play around with, because that has both discrete and continuous variables. But for this tutorial, we're going to keep it fairly simple and have a look at the Bayesian network. So we'll single click on that here to open it. Let's make the display a little bit larger for this video. Now, we might be looking at this has bronchitis variable here. And what we're really interested to know is, what's the difference between when that's true and when that's false? So you can see when I click on true versus false, all the other variables change, but by how much? So yes, we can see visually how things change, but it's hard to keep track of all the other variables, and we've only got 8 or 9 here. Imagine if you had 100 variables, it would be incredibly difficult. Also, we're just eyeballing it, so we're kind of just guessing. I mean, we could note down all of these values, switch to false, note down all the other values and do the calculations in a spreadsheet. However, there's some easier ways to do this. So another way we could do, rather than just eyeballing it, is perhaps we could use the scenario features. So we could add a new scenario in here on the right. Let's just leave it with a default name for now. So now you can see we've got two different scenarios, the blue and the green. So we could set the blue scenario to true and set the green scenario to false. And now we can actually slightly easier visualize all the differences amongst all the different variables. Still, if we had hundreds of them, it would be quite difficult. We're not getting proper stats back and we're still eyeballing it. So if you wanted this to become part of a diagnostics application and it's fully automated, you might not have this visual available. It might be something in your own application. So tools like Auto Insight can be really powerful because they'll automate all of this. The other thing I should say at this point is that the Auto Insight tool is very similar to the pattern analysis tool. They just visualize things slightly differently, and the Auto Insight tool allows you to perform slightly more complex drill down. So in some cases, the pattern analysis tool is simpler because it visualizes things very simply, but the Auto Insight tool is probably more comprehensive once you get the hang of it. Okay, so let's remove that scenario here and carry on with the tutorial. So to activate the Auto Insight tool, we'll first select the variable of interest, and then we go to the Analyze tab, which is where all of the analysis tools are. And under Insight, both Auto Insight and Pattern Analysis are grouped together here because they're quite similar tools. But in this tutorial, we're going to consider the Auto Insight tool. I should mention that we're following this Auto Insight tutorial, which can be found on our help pages here. We will include a few bits of extra information in this tutorial. However, we are broadly following this. So you can see that we've been asked to open the Bayesian network, select that particular node, and launch the Auto Insight tool, which we've done. We're going to consider just has bronchitis equals true for the target. So we're going to deselect has bronchitis equals false. Everything else we're going to leave as default, and then we just simply click run. And then we can immediately see the results. So what's happened under the hood really is that the algorithm has set evidence on one state, essentially recorded a bunch of stats, and then set evidence on the other state, recorded it, and then calculated some distances between the distributions and so on. So we can see here on the left, this is where we see our drill down panel. At the moment, we're considering the network with no evidence set, but if we wanted to, we could have previous evidence already set on the network before we launch this tool. Now on the right, you can see that in this case, we're only considering has bronchitis equals true. So the first two columns are always going to be has bronchitis equals true. So we can ignore those for the purposes of this tutorial. And we can see that it's ranked all the other variables based on how much they differ between has bronchitis being true and false. So we can see that in this case, dyspnea seems to be the variable that changes the most between those two different states. And it automatically ranks on this distance column, which is a divergence called Jensen-Shannon divergence, and that goes between 0 or 1, or in this case we've displayed it as a percentage, so 0 and 100. So we can see it's quite a big difference between has bronchitis equals true and false for the dyspnea variable. Now if we go back to the network quickly, you can see this in action. So if we quickly flick between these two and look at all the different nodes, you can see smoker above changes quite a bit, but the biggest change is down the bottom in the dyspnea node, where the values change dramatically. So it's showing us what we'd expect. So let's quickly go back to the analysis tool, and we'll go back to where we were. So what exactly is this distance? Well, it's the Jensen-Shannon divergence, as I mentioned. We don't have to use this as our sort column. There's other options in here, so we can look at the insight objective. Are we interested in the biggest patterns or just patterns of any size, such as anomalous patterns and so on? So there's different ways we can rank this, but the results will be the same. It's just the sort order that changes. So we could come in here and then sort by lift to look at the most anomalous patterns if we wanted to. So as a slight divergence from the tutorial, let's just go and have a look at how this value is calculated. So in Bayesian, we can calculate the Jensen-Shannon divergence, which is a divergence calculation between two different distributions. And we could do this by, again, let's go back and add our scenario in here. And then let's set blue to true and green to false. And if we look in the query tab, information theory, and then select Jensen-Shannon divergence, again, we've got evidence set on one scenario, in the default scenario, which is has bronchitis equals true, and scenario 2 up here is the other scenario where we've got has bronchitis equals false. And in this case, we're interested in dyspnea. So we're looking at the Jensen-Shannon divergence for where X is dyspnea. Now we could add multiple variables in here. It supports that. They could be discrete, continuous, etc. But if we click query, then you'll see that the result of this in bits is 0.36. And if we look at this, basically the result is bounded by 0 or 1, or if we multiply it by 100, it becomes a percentage. So let's just remember that, 0.36 roughly. Okay, so let's double check that result. So let's remove the evidence on these two scenarios here. In fact, we'll actually just delete that scenario. We'll select has bronchitis and then go back into the Auto Insight tool. We'll deselect this as before and run. And as you can see, we've got 36.36%, which is equivalent to our 0.36 out of between 0 and 1 expressed as a percentage. Now let's go back to the tutorial. What we're going to do now is we imagine the scenario where we've gone back to the patient and done a test on them to see if they do indeed have dyspnea or not. Dyspnea, it basically means shortness of breath. So in this case, let's say we tested the patient and it came back that no, they don't. So there's a couple of different ways we can approach this. We could close out of here, set dyspnea equals false in the network, and then rerun the analysis. But this tool actually lets us do dynamic drill down. So we can come in here, look at this dyspnea equals false line and click set. Now set versus do, set just means we're observing the variable. Do is to do with interventions and causal AI. So, for today's tutorial, we're just going to click set because we've observed this. And now you see it's rerun the analysis. On the left, on the drill down, we've got two levels. We can switch between these two by clicking on them. But now this second level is conditional on dysmia being false, and it's basically rerun the analysis. And now, as perhaps you might expect, you can see that the one that's got the biggest distance is actually now smoker. So this is pretty useful because it allows us to do dynamic drill down very, very quickly, and all the results are automatically ranked for us, which is very hard to do just visually in the network. And particularly if you're using the API, this is incredibly useful as well. That pretty much concludes this tutorial. However, as a couple of optional steps, we can look at a network that has both discrete and continuous variables, and also a slightly more advanced network which has something called a latent variable. And AutoInsight's useful in both cases. We'll close that down. We'll open up a different network here, which is another built-in one, but it's called the waste network. And you can see now we've got 3 discrete variables at the top, and all the others are continuous. However, that's fine. The AutoInsight tool supports that fully. So let's say we're interested in filter efficiency. Again, we can go to Analyze, Insight, AutoInsight. Now, because filter efficiency is continuous, you only get a single state here because it's continuous. And also the insight objective defaults to something different in the purely discrete case, because we're not looking at individual states so much. We're looking at the largest patterns by variable. We can still change it here, but then some of the items might be blank in the continuous case. And that's pretty much it. So let's run that and see what we get. This may take a little bit longer. You can see it was a little bit slower, and that's because there's some discretization and sampling going on under the hood because there's continuous variables. So we won't talk too much about the results here, but again, if you want to, you can drill down and set evidence on these things. But in this case, it won't be clicking on a state or equivalent to clicking on a state. You'll be entering a continuous value here. And then one last example, which is slightly more advanced. Feel free to skip this section. So let's open up a different model called the iris network. And we've got we've got 5 variables here. We've got 4 which happen to be in a single node, and we won't go into why that's useful in this video. And we've got another special one here, which is called cluster. Now this is a latent variable, and this allows our model to be more expressive. A little bit like hidden layers in a neural network or deep learning, but not quite the same. So for example here's a slightly simpler model where you've got 2 variables x and y, but then this data itself doesn't really conform to a standard normal distribution or something like that. There seems to be like 3 distinct clusters which correspond to the 3 different states in this model. So there's no data necessarily that tells us which point belongs to which cluster, but the algorithms within Bayesian can learn with essentially missing data. So, and in this case, we might want to analyze the difference between the clusters. So we could click Analyze, Insight, AutoInsight, and look at the different clusters, run this, and then we can see essentially what the characteristics of each of these hidden clusters is in our model, which is hugely powerful. So all the results are ordered, and we can see that the key characteristics coming out for cluster 2 in particular are both petal length and petal width, with a distance of 99.8 and 98.2, so very high. We can see that the mean or the normal distribution for this is 1.46 and 0.244 respectively. So there's something about cluster 2 that looks different with regard to these variables. They're different than the other clusters, and that seems to be key. So what we can do is let's quickly plot this data. So if we come out of here and let's go to the query menu, and what we're going to do is create a mesh query or a mesh plot. So what we can do here is we can say, let's put one variable on the x-axis and another on the y-axis, and then calculate a third value. We'll then make multiple queries along the x-axis and y-axis, forming a grid or a mesh, and then we can plot the results. So what we're really interested in here is we're going to choose petal length and petal width. because those were the key characteristics coming out of the cluster 2. And on the z-axis, we're going to plot the likelihood. So let's run this and see what happens. And then let's just do a plot, a 2D plot. Okay, so what we can see here is that there seems to be a number of different clusters, and this one here actually corresponds to cluster 2. And you can see that it's very different in these values from the other parts of the data set. And that's why that Auto Insight picked it out, that cluster 2's characteristics were very high for those particular variables. So it's very, very powerful. Okay, so that wraps up this tutorial. Thanks very much for watching, and do subscribe and like this video if you want to see more. Thanks again.